Case studies of environmental issues. Environmental physics is concerned with understanding and predicting the physical processes that shape the Earth's environment. It provides unique perspective to analyze and address environmental problems, including global warming, air pollution, water pollution, and land degradation. In this section, we will discuss these environmental issues and their analysis from a physics perspective. Number 1. Global warming. Global warming is the gradual increase in the Earth's average surface temperature due to buildup of greenhouse gases, primarily carbon dioxide in the atmosphere. Environmental physics provides a framework to study the causes and consequences of global warming. It uses various models and simulations to understand complex interaction between atmosphere, ocean, land surface, and cryosphere. These models use fundamental physics principles such as thermodynamics, radiative transfer, and fluid dynamics to simulate the Earth's climate and predict future changes. By analyzing and understanding the underlying physical processes, environmental physicists can develop strategies to mitigate and adapt to the impacts of global warming. Number 2. Air pollution. Air pollution is the presence of harmful substances in the air, such as particulate matter, nitrogen oxide, and sulfur dioxide. Environmental physics play a important role in understanding the source, transport, and fate of air pollutants. It uses atmospheric models to study the dispersion and deposition of pollutants and their impact on human health and the environment. Environmental physics also study the physical and chemical properties of pollutants to develop effective mitigation strategies such as emission controls and air quality monitoring. Number 3. Water pollution. Water pollution is the contamination of water bodies such as lakes, rivers, and oceans by harmful substances such as nutrients, chemicals, and microorganisms. Environmental physics provide a quantitative framework to study the transport and fate of pollutants in water bodies. It uses fundamental principles such as fluid dynamics, heat transfer, and mass transport to model the transport of pollutants in water. By understanding the underlying physics, environmental physicists can develop effective strategies to reduce water pollution, such as wastewater treatment and watershed management. Number 4. Land degradation. Land degradation is the destruction of land's productivity and ecological function due to natural or human induced factors such as erosion, desertification, and deforestation. Environmental physics play a vital role in understanding the physical processes that contribute to land degradation. It uses model and simulations to study the soil, water, plant, atmosphere interactions that drive land degradation. By understanding the underlying physics, environmental physicists can develop strategies to restore degraded land and prevent further degradation. In summary, environmental physics provide a powerful toolkit to analyze and address environmental problems such as global warming, air pollution, water pollution, and land degradation. By understanding the underlying physical principle, environmental physicists can develop effective strategies to mitigate the impact of these environmental problems and promote sustainable development.